I wanted to highlight a couple things from the board problems. It's always nice to see the class get them all correct, but maybe you're saying, yeah, but I don't really know what's up with 28. Okay, you're not alone. Did you notice something was different about 28? Let me just highlight, though, before we get to 28, something like number 15. What is shown here is 100% right. You can change sine squared to 1 minus cosine squared. You end up with a cosine squared that you have to square root, and you end up with a plus or minus. It's like plus or minus 1/2 right here. There is another way. It's also 100% correct. And I'm not going to go through the whole thing, but I just want to mention that if you initially saw the potential to divide the cosine squared and make a tangent squared, again, I want to say that is also correct. You would get a tangent squared that would equal 3. And actually, you're ready to take the square root and get a little plus or minus. Now, you won't get the same two answers. You actually get a different set of answers, but they're still correct. Okay, and tomorrow you guys will get more problems where you'll realize, oh my gosh, I could do it different ways. That's a really good example of that. Same thing with number 21. Nothing up here is wrong. Okay, but I want to show you that if you had sort of seen or said that instead of dividing tangent, that you would subtract tangent. If you would have said subtract tangent, well, now the equations equal to 0. And we said yesterday when equations are equal to 0, you can factor. Now, take a look here. Take a look. It's interesting. I'm still doing something with a tangent. But instead of dividing it away, I factor it out. And what that actually does is allows me to get some more answers. Okay, now I end up getting some of the same answers that happened here, but I also end up getting like a different set of answers for this factor. I don't want to spend too much time on it, but I just want to share that there's sometimes different ways. Divide tangent, factor tangent. Okay, it ends up producing a little different set. Now, with 26, I don't know if you, I hope I'm not putting you on the spot here, Nick, but if you had to kind of say what was kind of the key step, or what was it that made you, it sort of dawned on you? Because it's a little trickier.
I know like the biggest aspect of it is that I ended up squaring the one section, both sides, and then from there I kind of just went down the process that we do in a sense.
Yeah, and what happened here? Cosine squared turned into this. How'd you know to do that? Nice little Pythagorean. Plus, everything is sines now. So when you change your cosine squared and 1 minus sine squared, everything is sines, which is, like you said, you're kind of going down through. Actually looks kind of like the problem I did in the notes yesterday after you get to that point. It's good. Okay, trying to give you guys things that you can start to grab onto, but again, nice job. 27. What was, can I ask, is there kind of something you're like, okay, now I get it?
I turned tangent into sine and cosine, and then that way I can cancel the cosines out. At least get the one. Wait, I'm sorry. That way I can get the denominator cosine and the next step out.
Yeah, that's good. It's seeing those denominators so that you can get that denominator to be common. It's a pretty neat problem. You end up with 1 over cosine equaling 2. Okay, but it was kind of all about those common denominators and a little Pythagorean identity to top it off. Now, I have a feeling Dustin knows, but number 28 and what I'm trying to get you to do up here, they're in the same family. Okay, what family is this? Some kids call it like an X method. Some kids call it like a trinomial. And I'm curious, what tool did you sort of, you said you pulled a tool out.
I didn't really like tools a lot. I just knew that what I had to do was multiply the coefficients and on the like the last part of the trinomial, like in front of negative cosine squared. I need to multiply -1 by the number in the very front, 2. And I'll just say like, what can I multiply to get -2 and add to get +1?
Yeah, now, spoken honestly like a true math teacher, that's exactly what the process is. I just curious how you'll say. Now, if you're like, what? He's just talking about factoring. But some people factor with x's. Some people kind of think about trinomials. Some people think about numbers that multiply and add. Okay. Now, what I want to do is give you a kind of a little, do you remember? And if you're like, no, then let's try to remember. How do you do it with, just regular equations, not with trig equations? But again, to see what happened in 28 is to realize that it turns into a trinomial. And this was supposed to be a segue into today's lesson. So we'll talk about it.
Is there a proof that involves that concept?
You mean basically like factoring? Or I shouldn't say basically, but factoring kind of like a trinomial? It depends on if you did it forward or backward. If you started on this side, maybe you did do that. If you started on this side, you might have not done that. So yeah, it could have happened. So where are you at? I heard some of you say a few moments ago you don't remember, but have you kept thinking about it? Or maybe just when you see this, do you remember? You're factoring. Now, I do want to share, and it's actually the same thing you heard Dustin say, that to come up with x minus 3 and x minus 2, it's really just to come up with numbers that multiply to be 6 and add to be -5. I hope that there was sometime a teacher that told you that, but if they didn't, it's that easy when the coefficient is 1. Now, you with me here? When the coefficient on x squared is 1, you can just think of numbers that multiply to be 6 and add to be -5. And some people really like these problems. They're kind of like little number puzzles. Remember, your answers, they're called the zeros. So we factored it, but our answers, as some students will say, they're like the opposite. You can write this down if you want. You can just kind of watch. This is just a little review from algebra. Now, this blue box, okay, that sort of ups the ante a little bit. The coefficient is 3 on the x squared. So now we have to think a little more. And some students learn something called a British method. Some people, again, like an X or a box. If I can just share the way that I usually teach this to kids, but I don't mind reviewing those other methods, is really just to think about numbers that fit the pattern. What pattern? Well, they have to be numbers that multiply to be -8. Let's understand, no matter what method you're using, the numbers have to multiply to be -8. Now, -2 and +4 is one option. It turns out that the reason it works is because I want it to check to be 10x. What do I mean check to be 10x? I mean that when you FOIL the 3x over to the 4, now if you FOIL 3x over to 4, you get 12x, right? And if you FOIL -2 to x, you get -2x. What were those two numbers again? 12 and -2. I get 12 from the outside, I get -2 from the inside, and those numbers check to be 10.
Is there like a method or something where like you split it in half?
Yeah, it's called the British method. You want to review it? Either period 1 and 2. So I'm happy to review it. Now, it was interesting. Maybe it was just the kids in the class, but they said it was never shown to them this way. So I got a little bit paranoid that I was doing something wrong. But I guess I'm curious what was shown to you guys. Here, let me just put this over here so I'm not all over the place. The British method, that's a lot of stuff to erase there. The British method, how I always have taught it, is to do this. And again, they said they were never shown, although it was the same thing, they just didn't see all these arrows. Now, the first arrows I drew tell you to take 3x squared and -8 and multiply them. I'm certain that is the right way to approach that. These dotted line arrows, I don't have to be dotted lines. I don't know. I always do it that way. You just bring down you just bring down both of these terms. So far, kind of easy. You just multiply some numbers, you bring down some numbers. This is the part where you have to do a little thinking. You have to do a little thinking. You have to split 24, or excuse me, negative 24, into two numbers that add to be 10, but still multiply to be negative 24. This is the part you have to think. So if you're like, you have to add to be 10, but multiply to be negative 24. And you have to do a little think of those two numbers. Are you thinking of, yeah, no, it has to be positive 12, right? Negative 2. By the way, the x really should be beside it because technically the x takes care of the x squared and also the x. There were some light bulbs that went off when I showed this the other period. What I'm suggesting there is that you have to group. It's called grouping. And you take out the GCF. So I not only group, but I take out the GCF. Basically, I factor. And here's where you know that you've hit the home run because these two guys are the same. And when those two are the same, they are one of the factors. And then these GCFs that I circled, they are the other factor. That is the British method. The reason it's the British method is because, and this is what, I feel like I drew this a little wrong. It's supposed to look like the British flag. At least from what I was told, that's why it's called that. Oh, you still have to solve the problem. Solve the problem. This is why we've talked about this for a few minutes. Now, if you want, I don't think it's a bad idea, but if you want, you could put that problem back on that folded notes paper from yesterday. Remember that second category? We only did one example. Did you leave space? I should have told you to leave some space. The second category was the factoring category. Do you have a way that you can put this in there if that's what you want to do? Here's the thing. No matter where you're putting this problem, you have to realize that it has the look. It has the look. What look? Well, people use different words to describe this. Some people say it looks like a trinomial. Good. I agree. It looks like a trinomial. Some people, they kind of think of like FOIL factoring. Some people think of a British method. But I want to just make sure that you guys open up your possibilities. I should say open up your factoring possibilities to something like this, where we have to come up with the binomials that would factor this equation. Listen, I kind of hope you're not overdoing this. Like, I kind of hope you're not doing a British method because you really don't need to. You just need to think cosine and cosine gives you cosine squared. And then, as it was said a couple times, numbers that multiply to be 2 and add to be negative 3. Like, it does work that way when the coefficient's 1. So numbers that multiply to be 2 and add to be negative 3. Right, 1 and 2, but of course negative 1 and negative 2. We get ourselves a little puzzle, and it's factored. Now be careful, okay, because we're not done. You have to solve this. Solving this means that cosine minus 1 equals 0. And we did that yesterday. So that means cosine equals 1. And you can either use a calculator or think about the unit circle. I hope you would say 0. 0 degrees. This one, though, this is the first time we've kind of officially talked about this today. This one is trying to say that cosine equals 2. Now, to say that cosine equals 2 is like a theoretical mistake. It's a theoretical problem. Cosine can't equal 2 because in theory, cosine is a value on the unit circle. 2 is too big. 2 is not on the unit circle. You put that in your calculator once or twice, you won't have to do it anymore. It never works. It never works when the number is greater than 1. Like I said, you can put in your calculator once or twice, but maybe save yourself some time. Okay, it'll never work when the number is bigger than 1. So we kind of have like a day 2 of equations. On day 2, I want to talk to you guys about some factoring, which we did here. I also want to just kind of give you some more problems to try. And that's on this sheet. My hope here is that we can go over a couple of these and that you guys can even try a couple of them. All right, that should be the same problem you have there. 2 sine squared plus 3 sine minus 2. It's got the look. There was a song in the 80s that said, "She's got the look." Anybody, do you remember the song? Oh, you guys weren't even alive. Okay, I'll try to pull it up. It's a good 80s tune. But this has the look. Okay, what look? It's the look of a trinomial. You know, what's a trinomial? Well, you have that squared term, you have that linear term. Now, how you guys doing? Are you kind of digging away at this? People factor differently. I have to be honest, when I have kids in Algebra 2 and I teach them factoring, I usually just try to teach them to do a little guessing and checking. Like, you might want to try this because the only numbers that you have to think about are numbers that multiply to be 2. Now, that would be like 2s and 1s, right? 2s and 1s. Now, I'm saying 2s and 1s because one of them has to be negative. Now, check this out, especially if you're kind of like want another way to factor. All you really have to do is check and see what happens. If you put a 2 out here, you're going to get a 4 sign. You're going to get a 4 sign. That's part of that FOIL. If you put a 1 right here, you're going to get a 1 sign or just sign. By the way, that is supposed to look like a forehead and smiley face. I steal that from Mr. Yost. It's the forehead and the smiley face method if you want another method. But all we're really doing is just kind of guessing and checking. Do you realize that these yellow signs need to add to be 3 sign? How do you make the yellow signs add to be 3 sign? You want the 1 sign to be negative. That means you want the 1 to be negative. You want the 2 to be positive. I'm not trying to overload you here, but that is kind of the basics of factoring, where you basically just guess and check until it checks to be 3 sign. You got to solve that guy. Okay, you still have to solve it. Basically, you got to do the inverse of a half. When you guys are doing that stuff on like a quiz or even a test, you show as much work as you need to. If you're just able to kind of just do that on your calculator and get 30, it's fine. What are we going to say about this one? Sine plus 2 ain't going to work. You're not going to be able to do a number that's greater than 1. Okay, so again, you can kind of save yourself some work there. Listen, if you're kind of feeling like you want to go off on your own here, I don't want to hold you back. I do want to, if necessary, talk to you guys about just a few more problems on kind of day 2. Basically, problems that are a little harder, but usually you're getting closer to being ready to do these. Listen, don't get too jumpy here. If you're trying to factor this, can't factor it. It's got 2 trig functions. If you have 2 trig functions, you want to make 1 trig function. Are you feeling like changing cosine squared? Changing cosine squared to be 1 minus sine squared. 1 minus sine squared. Okay, now I hope that that's something that you're building into your sort of your methods, because your methods should be telling you that you want everything to be sine. If you distribute, I know you guys know how to do that, but you kind of have to be willing to distribute and kind of clean this up a little bit. Basically, it's a trinomial. You have to clean it up. The circled numbers are like terms, but once I get it organized, I can see that it's got the look of a trinomial. I don't like factoring when the leading number is negative. Is that something that you've kind of grown to not like? If you don't want the leading number to be negative, just multiply everything by a negative. If you multiply everything by a negative, it's still the same equation. 2 sine squared plus sine minus 1 equals 0. Two sine and sine. 2 sine and sine. It's really the only way to split up 2 sine squared. Negative 1. Well, kids, the only numbers that multiply by negative 1 are 1 and negative 1. Now, do we know? Do we know which one's which? You got to do a little thinking. You got to do a little thinking about this. Kind of looks like a forehead and a smiley face. Which one do you want to make negative? So, you were correct. But why? Why is that correct? Why do we want to make this first one negative? Well, if the second one's positive, that gives us a 2 sine. If this one's negative, it gives us a negative sign. Some of you can just kind of do that in your head. That's fine. But the yellow 2 sign and the negative sign are going to work out to be the sign in the middle. I'm talking about this plus sign right here in the middle. I'm not going to give you guys one that, has a ton of options. Usually if there's a ton of options, then the British method is helpful. But sometimes you just have to think a little bit about the FOIL method. Make sure you solve those. I've said a few times that at this point, if you can just solve that on a calculator, that's fine. But you're basically getting the inverse of a half. The inverse of a half is 30. We've seen that a few times. And then the inverse of negative 1, that's going to be negative 90. Hey, don't forget about checking your solutions. I forgot to mention on the homework, but I forget which one. It was right in the middle there, that one of those problems in the 20s. I think it was the one that Nick put up, that one of the answers was not going to work, so we just crossed it off. We don't need to check those. There's no fractions. I'm just saying don't forget. Okay, one more problem. And you guys, I want to give you a little bit of time here, but be careful. We've got all these fancy things going on. We've got all this fancy stuff going on, but now that I say be careful, can you just pick something simple? Something simple would imply that we don't need to square it. We don't need to factor it. We just need to see how to get something to cancel. I showed yesterday that you can divide. This is a good example of using that option. Right? If you divide by cosine, good things happen. So you're allowed to do it. And I guess I would say, why not? Because you can get tangent plus 1 equals 0. Okay, now we're kind of at the point here where it's sort of your turn to try to put all this together. We're actually going to keep practicing this stuff tomorrow. Tomorrow I have some problems that are even more advanced. Each day we're trying to build a little bit. And that's what this little practice sheet is trying to give you a chance to keep building. I mixed up different problems on here. There's some answers on the back. Let's put this in like a homework category. It's not an assignment, but put it in a homework category and see if you can keep understanding how to solve equations